Hi, I'm Owen.
I'm Justin.
This is James right here. James, say hi. Hello there.
And that's Charlie, our cameraman.
And we all put our heads together to try to create an artificial tree strengthener. And this is called the Carbon Fiber Root Strengthening Design Model.
So, what we did, this is just part of a screen door, but it's supposed to be,
Represent carbon fiber.
And what it does is it goes down in the soil and slightly above the soil too, which strengthens the base of the tree, and then underneath, so that the roots will go underneath the carbon fiber, so it would branch deeper into the ground.
And that would protect against like hurricanes and wet soil. So you see, it's pretty sturdy. And
As a base, good strong.
Yep.
Base in the roots.
So, and the here it's connected with copper wire.
But in real life,
it
would be fused together because this is representing carbon fiber, which is stronger than titanium, so it should be pretty good.
This is an actual piece of carbon fiber. The price of carbon fiber is going down, so making the strengthener would be cheap and affordable. And carbon fiber is also used to make lots of cars, bikes, and airplane parts.
And also, since it's a fiber, this is just super strong woven fiber for a bike seat to hold up the seat. But water can get through it, so the roots can be strengthened with the water too. It's not like no water can get to them.
And and it just because it's woven, it doesn't mean that the roots can go through it. They'll be forced to go underneath and spread out or cut.
This system is meant for new trees. It would be extremely hard to dig up a tree pretty much and put this in, and it would probably hurt the tree. So we're meant for like the next generation of trees.
And it's meant for like around communities and schools where the fallen trees can damage buildings and harm lives. And so we've constructed little miniature roots inside, and so we're going to simulate the winds of a hurricane using a hammer, and so we'll see how it works. As you see, it's still up and still strong, so yes!
And also, a tree in Hurricane Sandy, since we live in New Jersey, lots of trees fell on our school property, and we didn't have school for a week, and this system could really help.
It could prevent.
Yeah, it could prevent
the next time something like this could have happened. Trimming spans on at high power, and we're going to see what happens after a couple hours of the wind coming at them from almost every direction. And we're going to continue to wet the soil to simulate the winds and rains of a hurricane. It has been sitting in the mud, and we've been continuing to douse the dirt with water, and a lot of water actually, and it's been sitting like that for about 2.5 hours. And as you can see, it still hasn't blown over. It's still quite strong there in the ground with the design attached.
And in a little bit, we will be taking this out and taking off our prototype for the tree and just putting the wooden dowel rod, the 2-inch dowel rod, back in the dirt to do a comparison to see
how it compares without the strengthening model. We took the strengthening model out to see how the plain wooden dowel rod would react to the wet soil and wind. And as you can see from the water line right here, it has been pushed over. And James, show the tilt. And it has been tilted this way, coming towards the wind. Going away. This can prove that our design model did help it stay up in the ground and is supporting the base of the tree.